We're going to dive into how life endures this frozen gauntlet. It's like this brutal obstacle course that nature throws down every single year. And to really get it, we need to go to a place where winter truly shows its power.
Yeah, we're talking about places like Minnesota, Wisconsin, the Dakotas. These spots aren't just a little chilly, they're basically laboratories for survival, where all the rules of the game are written in ice and snow.
For every single plant, every animal, every tiny insect, it all comes down to this fundamental test of its own biology and its behavior. You pass, you get to see the spring. You fail, and you become part of the frozen landscape.
So how in the world do they pass this test? Well, believe it or not, this incredibly complex siege can be boiled down to just three core problems. You solve them, you survive. That's it, just 3. And it doesn't matter if you're a tiny little beetle or a massive bison, the rules of the game are exactly the same for everyone.
Okay, problem number 1 is the most obvious. You have to solve the cold itself. I mean, it's a direct assault on your cells. So what do? Do you generate your own heat, or do you find some way to let the ice in without it literally killing you? All right, next up, you're facing a massive energy crisis. Your body is basically a furnace that constantly needs fuel, but guess what? The pantry is completely locked. The only way you're going to keep that fire from going out is to become unbelievably efficient, saving every last little spark of energy. And finally, even if you solve the first 2 problems, you've got to solve this one, survival of the sneakiest. The landscape is bare, it's white, and there is absolutely nowhere to hide. Predators are desperate, and you are totally exposed. So how do you avoid becoming someone else's emergency meal? Over eons, life has developed 5 master strategies. You can migrate. Just get out of there and flee the cold entirely. You can go dormant and basically sleep through the whole siege. You can stay active and face winter head-on. You can even resist freezing at a cellular level. And then there's that 5th strategy. Just let this idea sink in for a minute. For countless organisms, the most successful survival strategy is to not survive at all. It's to die. But in their final act, they pour every single last ounce of energy into creating the next generation. A frost-proof seed, a tough little egg, or a spore that can endure anything winter can throw at it.
First, we have to understand the number 1 enemy for any tiny creature in the cold. And it's not just about the temperature dropping. It's something much, much sharper. Think about it. Every living cell is basically a tiny bag of water. But when that water freezes, it expands and forms these super sharp, jagged ice crystals. Inside a delicate cell, those crystals are like millions of microscopic daggers, just shredding everything from the inside out. It's a really brutal way to go. So, how on earth do you survive that?
Well, strategy number 1 is pretty clever. You fight chemistry with more chemistry. If freezing water is the problem, you just change the water. It's this incredible biological wizardry, and it all happens on a molecular level.
The secret ingredient here is a group of substances called cryoprotectants. And you can basically think of them as nature's version of the antifreeze you put in your car. These things, mostly glycerol and some special sugars, actually lower the freezing point of the water inside their cells. This means they can get much, much colder without turning into a tiny popsicle.
And for this, let me introduce you to our hero, the goldenrod gallfly larva. This little guy spends its entire winter locked inside one of those round galls you see on old goldenrod stems. I mean, it's completely exposed, there's nowhere to run, nowhere to hide from the freezing cold. This larva doesn't just avoid freezing, it leans into it. By pumping its body full of those cryoprotectants, it actually controls where the ice forms. It lets up to 65% of the water in its body freeze solid, but it keeps the ice outside its precious cells. So it just waits, partially frozen solid, and then it just thaws out and comes back to life in the spring.
What if you can't brew your own antifreeze? Well, the next best strategy is to just check out. You basically hit the pause button on your entire life. This biological timeout has a name. It's called diapause. And this is so much deeper than hibernation. It's a complete, system-wide shutdown of development. As the days get shorter in the fall, it triggers this state of suspended animation, and their metabolism slows down to almost nothing. We've got insects that can literally freeze solid, and others that just hit pause. But believe it or not, the story gets even stranger. What about the creatures that don't hide at all? The ones that actually look at all that snow and cold and see a playground?
You can probably guess the answer is a big, resounding no. There's this whole secret world of activity happening right on top of the snow. You have to know where to look. So, picture this. On a slightly warmer winter day, if you look really close at the surface of the snow, you might see something that looks like someone just spilled pepper. These tiny little black specks, and then suddenly, they jump. Now, these guys are not fleas at all. They're amazing little creatures called springtails. And they are part of a very, very exclusive club of insects that stay active all winter long, just hopping around on the snow. They produce these special antifreeze proteins. Now, these proteins don't just lower the freezing point, they actually find tiny ice crystals as they start to form and physically latch onto them, stopping them from getting any bigger. This is what lets them stay liquid and active, just munching on algae and spores right on the surface of the snow. Okay, for our last survival strategy, we need to leave the snowy land behind and look underneath the surface of a frozen pond. Because even under a thick sheet of ice, there's a whole world down there that is very, very much alive. And this isn't just about surviving, it's about strategy. By continuing to eat and grow all winter long, these aquatic insects get a massive head start on everyone else. The second that ice melts, bam! They are ready to emerge as adults way before many of their land-based cousins have even woken up.
It sounds like something straight out of a sci-fi movie, doesn't it? An animal that becomes a block of ice, its heart stops, it stops breathing, and then, when spring rolls around, it just thaws out and gets on with its day.
So our first stop on this tour of winter survival is the humble frog. Now, frogs have a pretty basic choice to make when the temperature plummets. Do you get out of Dodge, or do you face the cold head-on? And it turns out, different frogs have very, very different answers. So, on one hand, you've got species like the green frog. They do the logical thing. Head to the bottom of a pond, bury themselves in the mud, and go into this kind of low-power mode called torpor. It's basically a deep energy-saving nap. Then you have the wood frog. It stays up near the surface under the leaves and does the one thing that sounds completely impossible. It lets itself freeze solid. So how in the world does it survive something that should be totally fatal? Well, the wood frog has an incredible superpower. The moment ice crystals start to form in its body, its system gets flooded with a really potent natural antifreeze. And that antifreeze is just glucose, basically sugar. While ice is forming around the cells in the frog's body, this super high concentration of sugar inside the cells acts like a shield. It keeps deadly ice crystals from forming within the cells, which would totally shred them from the inside out. So when the thaw comes, the engine can just restart. Next up is the painted turtle. It also spends the winter at the bottom of a pond, but its problem isn't really about freezing. It's facing a completely different, and you could argue equally deadly threat.
Just try to imagine this for a second. You're trapped under a thick sheet of ice for months. There is practically no oxygen to breathe. For most of us, that's a death sentence in minutes. But for the painted turtle, it's just another Tuesday, well, another winter. So here's their survival plan. First, they drop their metabolism to almost nothing. Then, they switch over to this backup energy system that works without oxygen. It's called anaerobic respiration. The only catch is this process creates a huge buildup of toxic lactic acid. But the turtle has this one last ingenious step to deal with all that internal poison. The turtle's own shell and bones start to absorb all that toxic acid, pulling it right out of the bloodstream. So in essence, its skeleton becomes this living chemical battery, safely storing all the bad stuff until oxygen is back on the menu in the spring. For snakes, getting through the winter is sometimes a group effort. You could almost call it an underground party.
For a snake, the number one goal is simple. Get below the frost line. If they get caught above it, they freeze, and that's the end of the story. So they're always on the lookout for insulated underground shelters. Natural rock crevices, old burrows that some mammal dug out, or even the crumbling foundations of an old barn. While some snakes might just spend the winter alone, a lot of species, like the garter snake, have figured out there is incredible strength and warmth in numbers. These communal dens have a name. They're called hibernacula. And by gathering together, sometimes in these massive balls of hundreds or even thousands of snakes, they create their own little microclimate that's more stable and a bit warmer. They're sharing body heat, they're reducing heat loss, and altogether, they are massively increasing the odds that most of them will see the spring. You see that picture of winter tranquility? Just a huge, quiet, snow-covered expanse? But what if I told you that just a few feet below where you're standing, a silent, intense battle for life and death is playing out?
So let's take a journey beneath the ice, because the very first secret of this hidden world, it's not nearly as cold down there as you might think.
4 degrees Celsius, or about 39 degrees Fahrenheit. That is the magic number. I mean, the air above can be brutally cold, right? But water is actually at its most dense at this temperature. And that layer of ice and snow on top, it acts like a giant insulating blanket, trapping heat and keeping the water below at this surprisingly stable, life-sustaining temperature.
So, for the fish living in this world, the biggest challenge isn't the cold itself. They're not going to freeze solid. The real struggle is all about endurance. It's about making it through a long, tough season with very, very limited resources. And to win this game, fish have developed this incredible playbook of survival strategies. I mean, they can't just go hibernate like a bear, right? Nope, they have to adapt in some truly fascinating ways.
The absolute key to their survival, the number one thing, is their metabolism. Think of it like their internal engine that keeps them alive. And to make it through the winter, they have to find a way to turn that engine way, way down.
So you get these game fish like bluegill, largemouth bass, and walleye. And what do? They all slow their metabolism way down. They become far less active, which means they don't need as much food, and, this is crucial, they don't need as much oxygen. A lot of them will find the deepest parts of the lake or seek out little underwater springs where the water's just a little bit warmer and has more oxygen.
But here's the thing. This whole survival strategy has a massive weakness. The entire system depends on one critical element.
This is where the real drama begins, because in certain lakes, especially the shallow ones, a long, harsh winter with a ton of snow can create a life or death problem that has absolutely nothing to do with the cold.
It's this dangerous chain reaction. First, that thick layer of snow and ice acts like a blackout curtain, completely blocking the sunlight. Well, without light, the aquatic plants can't do photosynthesis, the process that creates oxygen. So the lake's life support system, it's basically shut off. And all the while, the fish and other organisms are still using up what's left, so the dissolved oxygen levels just start to plummet.
And this leads to a phenomenon with a very direct name. It's a silent crisis that unfolds completely out of sight beneath our feet.
It's called winter kill. And let's be clear, the fish aren't freezing to death, they're suffocating. As that oxygen just runs out, huge numbers of fish can die, simply unable to hang on until the spring thaw.
But here's where it gets really, really interesting from an ecological point of view. Winter kill is not an equal opportunity event. It acts as this powerful force of natural selection, favoring some species and absolutely hammering others.
The outcome of this annual drama, who lives and who dies, has this profound, lasting impact on the entire ecosystem of the lake. The survivors, well, they literally get to define the future.
Okay, so picture this. The temperature drops, the snow starts to fall, and all the easy food is gone. Every single bird out there faces this critical choice. Do you stick it out and tough it out, or do you just leave? It's a really high-stakes decision, and it's led to 2 totally different but equally brilliant strategies for survival. All right, so let's talk strategy number 1. And honestly, it's the one you'd probably think of first. If things are getting too cold and there's not enough food to go around, why stick around? You get out of there. It's a massive undertaking that we, of course, call migration. So who are these travelers? Well, here in the upper Midwest, it's a huge number of birds. We're talking about all kinds of warblers, those beautiful orioles, the acrobatic swallows you see chasing insects, and of course, you've got tons of shorebirds and those massive, unmistakable flocks of ducks and geese. They all basically pack their bags and head for warmer weather down south.
Migration is a massive gamble, a real high-stakes evolutionary trade-off. The journey is incredibly dangerous, and it burns an unbelievable amount of energy. I mean, these birds literally have to pack on so much fat, they almost double their weight just for the fuel. But the reward for taking that huge risk? Plenty of food and way better weather. For them, it's a gamble that absolutely pays off.
Okay, so that's the escape artists. They've made their call. But what about the ones that stay behind? For this tougher crowd, winter isn't something to run from. It's a challenge to be outsmarted, a puzzle to be solved with some serious ingenuity.
And that, of course, brings us to strategy number 2, the tough it outers, the resilient residents.
These are the birds that have figured out, through evolution, how to not just get by in the winter, but in some cases to totally own it.
And our poster child for this strategy is probably a bird you've seen a million times at your feeder, the black-capped chickadee. Seriously, don't let its tiny size fool you. This little bird is one of winter's absolute toughest survivors, and it pulls it off not with brute force, but with some seriously clever planning and a few physiological tricks up its sleeve. I mean, this little guy's survival kit is just unreal. First off, it bulks up with a super fluffy, extra dense coat of downy feathers. Then it spends the fall stashing thousands of individual seeds and insects in all these tiny little hiding spots. And get this, the part of its brain that handles memory, the hippocampus, it actually gets bigger in the fall, just so it can remember where it hid all that food. All right, let's go from the tiny planner to our next expert in winter survival, the ruffed grouse. Yeah, if the chickadee is the brainy planner, the grouse is the master of living in a world of snow. This bird is physically engineered for the deep freeze. The grouse's whole toolkit is just perfectly designed for snow. First, its legs are feathered all the way down to its toes, like built-in leg warmers. Then, on those toes, it grows these little comb-like scales that act like snowshoes so it can just walk right on top of the snow. When everything else is buried, it just switches to eating buds off of trays. But its coolest trick? It uses the snow itself as a blanket. And hey, it's not just them. You've got wild turkeys, all kinds of woodpeckers, even big predators like the great horned owl. They're all part of this club of winter warriors, and they've all got their own unique strategies for making it through. So how do they really do it? I mean, it's easy to say, oh, they're tough. But how? What are the actual biological superpowers that let them pull this off? Let's get into the nitty-gritty, the incredible physiology that makes this all work. Okay, first up is this absolutely brilliant piece of biological engineering called countercurrent heat exchange. I know it sounds super complicated, but the concept is actually pretty simple, and it's crazy efficient at saving energy. So here's how it works. You've got these arteries carrying warm blood from the bird's core down to its chilly, unfeathered feet. Well, running right next to them are the veins, bringing that cold blood back up. And because they're so close, the warm blood in the arteries heats up the cold blood in the veins before that precious heat gets lost to the frozen ground. It's a perfect, built-in heat recycling system. Yeah, so fluffy feathers are one thing, but the real secret weapons for these birds? They're internal. Their physiology is just built for this stuff, letting them pull off feats of energy conservation that are, frankly, mind-blowing. And if you want a number that'll really prove it, here it is. At night, a chickadee can drop its body temperature by 10 to 15 degrees Fahrenheit on purpose. It's this state of controlled nightly mini hibernation called torpor. And doing this saves a ridiculous amount of energy that it would otherwise burn just trying to shiver all night. Okay, let's circle back to the grouse for a second. You know, for most of us, a huge pile of snow is an obstacle, right? Something to get through. For the grouse, it's a solution. It's a tool. It's a cozy blanket. Just check out these numbers for a second. A grouse will literally just dive headfirst into a soft snowbank to sleep for the night. Outside, the air could be brutally cold, way below freezing. But inside that little snow cave, its keep, it can be 20, even 30 degrees warmer. That's all thanks to the insulating power of snow. And one last thing. Let's go back to that chickadee's brain. It's just too cool not to mention again. That brain isn't just randomly stashing seeds. It's a super-powered GPS. We're talking about remembering the exact location of thousands of individual seeds and bugs it's hidden, and it can find them again with stunning accuracy, even after they've been covered by snow. Think about it. Food? Suddenly gone. The cold is just relentless, constantly draining your energy. Every single day is a test, pushing these animals to their absolute limits. And yet, they do it. They survive. So how? How on earth do these creatures, from a mouse you could hold in your palm to a massive bear, engineer their way through the deep freeze? Okay, Section 1, the survival gauntlet. For every single mammal out there, winter comes down to a really simple but ruthless equation. You have to find enough energy to stay warm, right when the food you need for that energy has all but disappeared. Every calorie literally counts. So, let's move on to the smallest mammals. How do they solve this impossible energy problem? Well, they perform a magic trick. They just disappear into a hidden kingdom right under our feet. And that kingdom has a name, the subnivean layer.
It's basically the little gap between the frozen ground and the bottom of the snowpack. And believe me, this little space is the key to everything for a whole world of tiny creatures.
I mean, just look at the difference here. Up top, you've got bitter cold, howling winds, and you're a sitting duck for predators. But just a few inches down, it's calm, it's safe, and it's so much warmer. It's like two different planets, separated by a layer of snow.
And here's the magic number, 32 degrees Fahrenheit. Snow is an amazing natural insulator. It traps the Earth's own heat. So it could be 20 below zero up in the air, but down in this hidden world, it stays right around freezing. That's a huge, huge difference. So who's down there? Well, this hidden highway is bustling with life. You've got deer mice, you've got voles, you've got shrews, and they're all busy creating these incredible tunnel systems, searching for seeds and grasses, completely hidden from the hawks and owls flying overhead.
And for an animal like the shrew, this isn't just a nice feature, it's everything. A shrew's metabolism is so ridiculously fast, it has to eat constantly. It just can't store fat. Without the warmth and the cover of the subnivean layer, it would be dead in a matter of hours. Simple as that. Okay, so that's the little guys, but what about animals that are too big for those tunnels? They can't exactly hide from winter, so they have to outsmart it. And their game plan usually falls into two camps. You either sleep through the worst of it, or you stock up your pantry like crazy. Now, a key tool they use is something called torpor. This isn't that deep, months-long sleep we think of as hibernation. It's more like a super efficient power-saving mode. The animal drops its heart rate and body temperature for a while to save energy, and then wakes up when things get a little better or when it's time for a snack. And you can see a few different approaches here, right? The chipmunk is the ultimate prepper. It has an underground pantry full of seeds and just wakes up from its torpor to eat. Raccoons are more opportunistic. They'll sleep through the nasty weather but pop out on a mild day to see what they can find. And then you have the beaver, a true engineer. It builds this amazing lodge with an underwater entrance and a whole pile of branches stashed nearby to eat all winter long. So let's talk about the giants of the cold. What do you do if you're too big to hide and too big to sleep the winter away? The deer, the moose, the predators, they have no choice but to face winter right out in the open. For them, it's all about transforming their bodies and their behavior. A white-tailed deer, for example, goes through a complete system overhaul. It grows this special winter coat where the hairs are actually hollow, trapping air just like a high-tech puffy jacket. At the same time, its metabolism slows way down to save energy, forcing it to live off the fat it spent all autumn packing on. And it's not just their bodies. Their whole playbook changes. They completely switch their diet from soft greens to woody twigs and buds. They'll gather in groups in what are called deer yards, packing down trails in the snow to make it easier to move around. And they get smart about using shelter, like hanging out in dense evergreen trees to block the wind. Of course, wherever the prey animals go, the predators have to follow, and you better believe they have their own incredible set of winter tricks up their sleeves. I mean, this is just a perfect example of coevolution. A fox can't see a mouse moving around in the subnivean layer, so instead it uses its incredible hearing to pinpoint the exact location, and then it does that famous high-arcing pounce, diving headfirst to punch right through the snow and grab a meal it never even laid eyes on. It's amazing. And finally, we get to the true master of winter survival, the black bear. Its hibernation is a biological marvel. The heart rate and metabolism just plummet, but its body temperature only drops a little bit. And get this, a pregnant female will actually give birth in the den, in the middle of winter, and nurse her newborn cubs for months, all while burning nothing but her own fat reserves. It's just mind-boggling. So, from the secret tunnels under the snow to the deep sleep of a den, these are strategies that have been perfected over thousands and thousands of years. But they were perfected for a world with predictable, cold, snowy winters. As our climate changes, as winters get warmer and weirder, you have to wonder, which of these amazing strategies will still work, and which of these creatures are best equipped to handle what's coming next?